Okay. Yeah, so I do have to run to the airport as soon as this talk is over, so I'm not going to go long. But I am going to leave plenty of time for questions, so I just have a few slides. And really, I just kind of want to go over some different strategies for thinking about how do we regulate robots. And these all sort of point towards the design of the robots and robot systems. And I'll talk about a few different approaches that all kind of converge on design. And then I'll talk in sort of general terms about some approaches to design and design methodologies that are applicable and that sort of exploit or think about ethics and values in specific ways. So the first way and the kind of most obvious way most people think about regulating stuff is law and explicit regulations in the law. And I talked a bit yesterday about these two kinds of perspectives on robot ethics, right? So there's the internal perspective where we try to build an ethical reasoning system of some kind or represent ethics within a computer system. And then there's the external view of just how do we sort of constrain systems to do ethical stuff, right? And regulation is all about that external perspective. How do we constrain and ensure that systems do what we want them to do and not what we don't want them to do? And the law itself is actually multifaceted. There's lots of different ways to do this with law. So mostly we think about criminal law, but there's all sorts of torts and liabilities law, things like that. And then there's these other, it's called administrative law. It's a whole other body of law that regulates various industries. So in the United States, we have the Federal Aviation Administration, the FAA, Federal Communications, FCC, the National Highway Traffic Safety Association, right? So if we're making small flying robots, the FAA is going to regulate that. If we're making self-driving cars, the Highway Safety Institute is going to regulate that. Right now, if you make a personal robot assistant, like nobody is really regulating that. So there's actually been some proposals to create a new regulatory agency in the U.S. to regulate robots that might sort of span these different things. The other one that's not here is the Federal Trade Commission, which regulates all sorts of commerce, and including all online commerce as well. And they're quite savvy about the technology of online like purchasing and sales and false advertising and stuff like that. So they might also have an interest in a lot of consumer robots and things like that. And there's equivalents to all of these within the EU. I don't know the acronyms, but maybe some of you do. And basically these are separate boards. They do their own reports. They come up with rules. There's public hearings about those rules and things like that. But the rules aren't generally sort of written by like Congress or political representatives. They're written by these administrative bodies, but they take consultation from what they call stakeholders, which is generally the industry. So in the FAA, that's going to be the airlines and maybe the unions that represent pilots and flight mechanics and things like that. Then you have these regulatory standards that are often set by Congress and often in consultation with regulatory bodies, and things like fuel efficiency, so that cars have to get so many miles to the gallon or kilometers to the liter over here, I suppose. And so there's ways to sort of put hard rules in. But a lot of the regulatory stuff is much more sort of vague and judgmental in many cases. But sometimes you have specific prohibitions or requirements. Systems have to do this, systems can't do that, and things like that. For aviation, all the planes have to have certain properties and qualities of how they fly, and they have to have transponders, and pilots have to be certified, and you have all different sorts of regulations, right? And this is all sort of law, so this is stuff that's written down either by lawmaking bodies or these kind of regulatory bodies. And that's very different than ethics, which is much more sort of nebulous, and we have rules and principles, many of which are self-adopted, but they're mostly social norms that we impose on each other. Law has the advantage that you can just rewrite it, right? And you can write it very specifically if you want to. It's very hard to change ethics. It's possible, but it takes much longer in some sense. And so there's actually interesting literature on how do you sort of look at different ways of regulating things through law versus through ethics. But what do we mean by ethics, and how does ethics actually get formalized in a lot of systems? And there's a movement towards ethical review boards within robot ethics as well, and AI ethics. There's a long history of what we call the institutional review boards that were created in the 1960s following controversial psychological experiments that put people in fake prisons as students and things like that, or pretended to shock people in the Milgram experiments and things like that. And so now we have informed consent and human subjects ethical requirements for the use of human subjects in research experiments, things like that. More recently, especially starting in the 1970s, we have a lot of medical ethics review boards looking at things like how do you treat human embryos, but also how do you treat lab animals and things like that. And many hospitals and large medical companies and pharmaceutical companies and things like that will have a formal medical review board or bioethics board within the corporation, right? And so if they're going to propose something, they'll have to get sort of reviewed by a medical review board or a bioethics review board, or those boards might come up with guidelines or principles. Especially in hospitals, there's a lot of discussion around end-of-life situations. So when is it appropriate to pull life support off of somebody, and who gets to decide that and how? And that'll often fall under bioethics review boards. So is there a direct correlate for robot ethics? Not exactly. More famously, or most infamously, I guess, Google, when they acquired the AI company DeepMind in London, part of the terms of the acquisition was that DeepMind insisted that they create an ethics review board internal to Google to consider the ethical implications specifically of artificial intelligence. But the idea is that it will actually be across the board of Google, or now Alphabet, I guess they're called, the corporate sort of ethics board. And it has very high-level people, the top lawyer and the CEO and things like that are involved. But it's very closed. So generally, the concept of the ethical review board is to make things transparent, right? So in IRB, they want you to disclose and have informed consent for human subjects before they participate in experiments and things like that. Bioethics is all about making explicit what the rules and ethical principles are that a hospital or a medical company is following. The Google DeepMind Ethics Board is completely opaque. We don't know who's on it. We don't know what questions they consider. We don't know how they resolve those questions. We don't know what ethical dilemmas there are. So on the one hand, they're trying to present kind of, we're doing ethics to the public, but they don't actually give any content of that to the public. So I think in many ways that's self-defeating of the whole point of having an ethics board, although hopefully they do something useful within the company. A different model we find at Lucid AI, which is Doug Lanatt's company that sort of came out of Psych, if you've heard of that, which is this large kind of common sense expert reasoning system that's been several decades in the making. And they have an ethics review board that's very much transparent. So that's a better model, I would say, of how to do an ethics board. But there's always a question for these things, like how much power do they have? So if there's an ethical dilemma that's arising from the design of some system, and the ethics board says, well, we think this, how does that actually impact the design? Do they change the design? Do they stop developing certain programs? Do they just change their pitch? And a lot of these ethics review boards, and what a lot of people consider ethics in corporate settings, tends to be law, right? Do we conform to those regulatory standards? As long as we conform to the regulations, then we're good. Can we get sued? No? Okay, let's make it. And so that's not really doing a lot of deep ethical thinking, I don't think. We've also seen in the last couple of years a lot of movement towards ethical codes of conduct. And these, again, are big in the medical profession. And generally, they're organized by professional organizations. And engineers have a long tradition of both professional organizations and codes of ethics. And many engineering programs in the United States actually require engineering ethics as a course for professional certification. So if you want to be a certified civil engineer or something like mechanical engineer, you have to take an approved ethics class as part of your education. But the professional organizations actually issue, all professional organizations for the most part have some kind of code of ethics. And those are usually pretty general, but they can be more specific. And we've seen in the last year discussions in the major artificial intelligence professional organizations, which is the AAAI, and the IJCAI, which is the International Joint Conference on AI, and also the big computer science and engineering professional organizations, the Association of Computing Machinery and the IEEE, have all sort of undertaken reviews or revisions of their codes of ethics to take account of autonomous systems and AI systems. The advantage to this is that as an engineer working professionally, if you're asked to build a system you don't think is right, you can always point to your code of ethics and say, I don't have to do this, and you can't fire me because this is a professional standard and I'm upholding this professional standard. And if they fire you, you can sue them because you're being a professional, right? Okay, so, but they're also generally pretty weak and vague. Don't do bad stuff, try to do good stuff. And this is a common theme in a lot of these, unfortunately. So the other way, and a bit better and more powerful, are the establishment of standards. And Joanna talked a bit about the EPSRC principles that were developed in Britain, and those have evolved into an actual standard from the British Standards Institute, which is a standard for robots and robotic devices, guide to the ethical design and application of robots and robotic systems. And this is like a 12, 15-page document that outlines different ways in which to consider ethical things when you're doing design. A similar sort of effort is underway, and multiple efforts actually at the IEEE. So one is a global initiative on ethically aligned design that's looking at autonomous systems and ethical design of autonomous systems. And there's actually like 15 or 20 subcommittees of that. I'm involved in the autonomous weapons subcommittee. But there's a whole range of things, self-driving cars and personal assistants and care robots and things like that. Affect. And affect, yeah. Affect. And that may result in a sort of guideline book or body of statements. So there's sort of a lot of it's about developing a statement and getting consensus over a broad group of people, engineers from different places, over what these general principles should look like. It's not necessarily a standard. The standard effort is the P7000. So this is a proposed standard. And the IEEE, they standardize things like Wi-Fi connections and things like that. But this would be a design standard for the model process for addressing ethical concerns during system design. And I'm also on this committee, which is quite large as a committee, but we're looking really at the process of systems engineering and design, and when and where and how do you consider ethics? How do you design a standard such that you can say, well, our system was designed according to this standard, which doesn't even then necessarily say it's an ethical system. It just says we conform to the standard for doing ethical consideration and addressing ethical concerns during the system design. Okay, so what is system design? So I found some nice good old-fashioned flowcharts from the internet. This is your sort of classic notion of the software design process. So imagine, 1960s IBM mainframe computer software design, right? So you're going to start with this kind of requirements specification, and then according to this, you're going to do an architectural design and an abstract specification of the system, and then you'll design the interface, and then you'll design the components, and then you'll design the data structures, and then you'll design the algorithms, and you'll sort of break down all of those pieces into their own specifications, and you give these to different teams, and they go off and code their things, and you stick it all together, and you turn the crank, and it all works wonderfully, right? So this, of course, is a completely idealized model. But if you're working in a large software development thing, and it's interesting, I think, that nowadays in artificial intelligence research, most of the researchers know at least how to program and code, but they actually don't learn a lot of software engineering. And really, software engineering and management information systems, how do you manage these large-scale software systems and their development? And that's like a whole nother branch of thinking about organizational process and software engineering and design. And I don't think a lot of people in machine learning and AI are actually looking at that. They're working in small groups, they're writing prototypes. They don't think about having to sustain code for 20 years. And even if we look at a lot of commercial software development now, especially around app culture, right? The goal is just to get software out the door, if it kind of works, and then we'll make updates and patches like next week, right? And then the week after, and the next week, and your phone is constantly telling you like, oh, all of your apps are out of date, you need to update them. Like, that's not how they did software engineering in the 60s. They built a program and, you know, it was going to go to the moon or whatever, and it's going to work for months and years, and you're not going to keep updating the software with bug fixes every 2 weeks. But that has really changed, especially with the internet, and it's possible to sort of re-release and continually release software. But this is a very different way of thinking about how to do it. But in this case, where's the ethics, right? Well, you know, each of these programmers is living in their little silo, in their little box, and they get a specification, and they design a piece of software to match the specification, and then all this stuff gets assembled by somebody else. And there's not a lot of room for really thinking through, like, where do these requirements come from? Are they accurate? What do they really mean? And so this is where I think a lot of these questions around ethics are about opening up these black boxes and thinking more openly about how do we think about the design specification? If we're the ones writing the design specification, there's a whole sort of set of considerations we should make around values and how to build those in. And so we should think about that process, and then we should think about, well, what are the values? And how do we think about values? And whose values? And this is what these different sort of design methodologies aim to do, is sort of emphasize these processes. Okay, so the first one, and it's sometimes called human-centered design. It's more or less the same thing as user-centered design. And there's a lot of different ways of articulating this, but the basic idea is that the user is the sort of customer or the most important person in the design process, and they're always at the sort of center, right, of the whole design process. But then this means, okay, so who are they? How do you define the audience? What are the scenarios of use for a certain system? How do we figure those things out? What is the work process of different people and the workflow? And then how do we start prototyping things and actually presenting those to users, right? And so then we can actually say, well, who are these users? Are they actually real people? Can we go talk to them? Or is these an ideal that we've sort of written down on paper, who we think the user are, where we as the engineer, not the user, right? And how do you evaluate that? Is that us thinking about what the user wants as engineers and saying, well, that's what the user wants, check that box, we did it? Or do you actually go and ask the user? And that's a really big thing. So to actually involve users, to talk to them in the design specification process. Well, what do you need the software to actually do? And that's a challenge, actually, right? So users don't necessarily know exactly what they need, right? Or they're not able to articulate it in the language that engineers necessarily understand or think about the system design in, right? And many engineers don't necessarily understand the users or what they're doing or what, you know, how they're going to use the software, what their job involves, what its demands are, and what their concerns are. So that's always a challenge. Another way to do this is what's called value-sensitive design. And this, instead of highlighting the user as a sort of person who's going to consume the software and use the software, we think about values themselves explicitly. And there's no sort of short way of doing this. It generally involves some form of brainstorming. And it's probably closest to what you guys were doing yesterday, and we're probably going to do more of today, Whereas engineers, you sort of sit together in a room and say, well, so how will this system interact with the values and ethics of people? So is that whether it's a healthcare robot or a policing robot or a self-driving car, what are the values? What values are important? What values are competing? Do we need to make trade-offs between certain values in the design of a system? And how could the system interact with those values? How should the system interact with those values? But again, this question of, well, whose values? Well, I'm sure you're all very creative engineers, but do you really know what those values are if you don't go out into the world and check or ask other people? That can be really challenging. And then, again, you can evaluate the system afterwards and see whether you've preserved certain values when the system is actually implemented. But it's basically a brainstorming technique, which has mixed reviews as a design process in itself. Brainstorming seems great because you come up with lots of ideas, but it doesn't always necessarily lead to the best ideas or the most effective ideas either. So a design process that I'm quite interested in and have a long paper on if you want to read more about it, it's called participatory design, and this is a rather old version of all of this, but it's still around. And the idea of participatory design is that you actually get users to participate in the design of systems. And you can also think about participatory design in a much broader sort of scope. So generally when regulatory agencies talk about stakeholders, they're talking about the industries that are going to sell products or buy products, right? And so it's a very small kind of conception of who is a stakeholder. They're generally not thinking about the public, even though all of those regulatory agencies are designed to protect the public ultimately. The public is never actually sort of represented as a stakeholder. Everybody else is the stakeholder. And participatory design sort of recognizes that it's not actually trivial to say, well, who's the user? If we look at office software, is the user the low-level office worker? Is it the manager of that office worker? Is it the IT director of the company that's going to be buying the software? And those people have very different perspectives on what the needs and requirements of a system are. And managers, even though they manage people that do specific jobs, don't actually necessarily know the details of the jobs that their subordinates are doing. They know how to manage those people. And so the way they might offer up a design specification could be very different. So a lot of the research around participatory design, it doesn't have these lovely little boxes and processes that we see in the old-fashioned design. It's a little more nebulous. It's more of a design philosophy, if you will, of trying to involve people in the design process and trying to do that communication work of saying, well, this is what a system could do for you. What do you need a system to do for you? What do you do in your work? How can the system help you do that? And doing that translation work between the users and the engineers to get a really good design specification to start with, and then to develop prototypes to say, well, it could look like this, or it could look like that, it could work like this, it could work like that, and have users actually engage with those prototypes and try to do their jobs as if that, they were using these prototypes, and then say, oh, well, that worked, that didn't work, we're going to change that. So you're getting this like very early feedback as well. And so this comes to a notion that's also popular and more generally in design, but I think is really crucial for participatory design as well, which is iterative design and prototyping as a big part of that. So this is a version of it in the sort of user interface design process, but you see there's feedback loops, right? So it's like we make a prototype, we evaluate the prototype with the users. Did it work? Did it not work? Let's go back and redesign it, make it better. And the more you can do that and iteratively improve it, the better the final product's going to be. And for ethical systems, that's also true. Like you're going to discover the values that are important by engaging with users and having users engage with the system and figure out like what sorts of problems actually do arise. And here's another version of it at the bottom, which is sort of gives you more of a timeline approach, and this is a kind of agile design concept that you're constantly testing and developing in very rapid kinds of iterations and design processes. Okay. So I just want to highlight some of the key issues apart from this sort of translation that happens, right? So you have the translation between users or the participants or the people who would be affected by a system and the engineers and the designers of that system. But you also have problems of translation from these standards and regulations, right, which are just sentences, ultimately. If some words, paragraphs in a regulatory framework or a standard that's been published, how do you actually turn that into a design, right? That's work we call translation, right? You're turning one set of ideas and concepts in one form of representation into some other form of representation. You can be taking human rules and laws, turning that into code. That's a process of translation. Taking design requirements and turning that into a system is a process of translation. And translation is always interpretation. You're always representing things. You're representing the needs of users. You're representing schematics of a system architecture. You're representing information, values, data, algorithms. All of these things are interpretations, and people will interpret them different. There'll be miscommunications. There'll be different ways to interpret that. There's not necessarily right and wrong ways, but we always have to be thinking about the ways in which these things can go wrong. And that's a big part, I think, of doing ethical design. And thinking about ethics in a deep way is that people are going to have different relationships to values along the way. So here's a list of papers. There's the participatory design paper on the top. And this 2009 paper also looks at value-sensitive design and ethical interfaces. So with that, though, I want to leave the rest of the time to have some discussion, see what you guys think about design. And I'm also curious how much, as engineers, or I think some of you are software or computer engineers, how much time you guys spend learning about design methodology or in software management in your education. Yeah.